So a computer network will be defined as the interconnection or interconnection of the computer system and some other smart cell gadgets for purpose of resource sharing. So information is scarce, and you want to make sure that you access a network as quickly as possible, or you want to access resources, network resources, as quickly as possible. Now, there are some benefits of having a computer network, and one of those benefits is that one, you can use it for resource sharing. What I mean by that is something like a file sharing, file and directory sharing. And secondly, it can be used for application sharing as well. And thirdly, it can also be used for network infrastructure sharing, so even for gaming activities as well. Now, no matter how large or complex a network is, a network comprises of three major component parts. So we talk about the component part of the network. So the first part of the network is you have end stations, and secondly, you have network devices, and the third component part of the network is the interconnection. Now, for the end stations, they define the source and destination devices. So you have something like PCs here, your tabs, of course your smartphones, and so on and so forth. Now, for the network devices, this is where you have devices such as hub. You have your hub here. You have your repeater. You have your bridge. You have your switch. You have router. You have IDS. You have your IPS. That's intrusion detection system, etc. You have firewalls here as well. Intrusion prevention system and intrusion detection system. You have your router, you have your switch, you have your bridge, you have your repeater, and you have your hub as well. For the interconnection, you have your media, which could be either wireless, Wi-Fi, or you have cable. Okay, then you have NIC, which is a network interface card. And lastly, you have your connectors. Okay, now, so the end stations, they represent the source and destination devices. Okay, so communication will be initiated from a source device and terminate on another end station, which is the destination device. Now, hub, it's the cheapest way, or the most simplest way of connecting your devices together. For instance, if I introduce a hub and I connect system PC1, PC2, PC3 together, hub is not an intelligent device, so it doesn't have any brain or any smart module that it uses to actually operate. So whatever that is being sent, for instance, if you want to reach PC3 from this PC1, now that information will actually be sent to all the end stations attached to that hub. So you can't actually make any intelligent decision saying, okay, you are sending packets from PC1 and we want you to get to PC, let's say PC2 here. This is PC3. So in as it's passing through a hub, it's going to be sent to both PC3 and PC2 down here. So if you have 10 computers coming to this hub and you send the information from PC1, the remaining 9 systems will actually get the information, even though you can't send it to just PC2 here. So that is how the hub operates on a network. Now, the repeater on the other hand is being used to regenerate a signal. To amplify a signal, okay, to make it go further. So that is what we use a repeater for in the network. Now, a bridge and a switch, both of them, they have the same functionality, a bridge and a switch, because both, of course, or both of them operate in data link area of USI model. So, a switch is also being referred to as a multi-port bridge, because bridge usually have a fewer number of ports, okay, fewer number of ports compared to a switch. The switch has a large amount of the ports. But in terms of speed, switches are also faster than bridges. Switches are faster than bridges. So because switches transmit the flame using hardware architecture, they transmit their flame using hardware architecture. That architecture is referred to as ASIC. That is application specific integrated circuit, ASIC. But like a bridge uses a software-based flame transmission. So, and of course, anything that's doing with hardware will always be faster than that of the software. So, switches are faster than bridges, okay, and switches are referred to as multi-port bridges, okay. So, a switch is what you use to connect your end stations together. Meaning a switch or a bridge. So if I say a switch anyway, I'm also referring to both. So whether you're using a switch or you're using a bridge, both can be used. Since I said they have the same functionality, so both are being used to connect end stations together. It simply means when I want to connect 50 computers together, 10 computers together, all those computers are going to be terminated on a switch first. Okay, so all computers attached to a switch by default, they are said to be on the same network. All computers attached to a switch by default, or a stack of switches by default, are said to be on the same network. What I mean by that is you can take a look at a switch as a device, let's say, that connects all houses within the same street or within the same estate. So if I have a street, let's say Kelvin Street, okay, and of course I have roundabouts here. This roundabout connects to Philip Street, okay. So this Kelvin Street, if I have like 50 houses here, you agree with me that all the 50 houses, all the residents here, they share one thing in common, which is Kelvin Street. They share Kelvin in common, meaning the first house could be 1 Kelvin, second house could be 2nd Kelvin, and so on and so forth. The last house here, since we have 50 houses, will be 50 Kelvin Street. Are we together? So what is common there? Kelvin is common to all of them. So meaning you are trying to deliver a letter from 1 Kelvin Street to 50 Kelvin Street, you know instantly that where you are sending that letter to is within your street. Why? Because Kelvin is tying the both of you together. So you know that that resident or that particular house can be found within your estate. So it is a switch or a bridge or a data link device. So both of them operate as a data link layer of USI model. So it is a switch or bridge that connects all the residents, okay, within the same network. In this case now, I'm likening that network to that street. So network, all devices within the same network will share the same network address. The same way all the residents within this Kelvin street will share this Kelvin ID. They share that together, meaning that Kelvin represents the network ID or the street ID. Okay, so it means all the 50 houses here, they share the same street ID, the same network ID. So it is the switch that connects all the stations together. The same way you have it connecting all the houses within Kelvin Street together. So a switch or a bridge or a layer 2 device determines the actual location of a station, an end station, a computer, okay, in the network. So now, what do you use a router for? A router, on the other hand, determines the network location of an end station, that is a computer, okay, it determines the network location of an end station. So it simply means, in this my diagram here, router serves as this roundabout. So if this roundabout joins Kelvin Street and Phillips Street together, what does it mean? It simply means the router connects multiple networks together. So this roundabout now serves as your router. Because this roundabout connects Kelvin and Phillips together, it simply means a router connects networks together. So a switch, another switch will connect all the houses. If I have 30 houses within Phillips Street, so a switch will connect all the houses within this Phillips Street again. But now, if you want to navigate from Phillips Street down to Kelvin Street, how do you go about it? Because if the device we are trying to reach is within the Phillips Street, you don't need to pass through this roundabout. I believe so. Okay, so because both source and destination nodes are contained within the same network, within the same street. Now, where you need a router is when you now want to move, you want to migrate from one network, that is from one street to another street. Because there's no way you get to this Kelvin Street. Let's say you are trying to reach 15 Kelvin Street from here. There's no way you reach this Kelvin Street, 15 Kelvin Street, without passing through this roundabout. That is, without passing through this gate. Okay, so you need to pass through this gate first, then your packets will now be routed to this other network. So it is a router that connects multiple networks together. Okay, so this gate that you pass through, this gate, this shaded area, is called a default gateway, a network, default gateway. It simply means for all the residents within this Phillips Street, for them to reach Kelvin Street, all of them must be aware of this default gateway. For instance, if the address of this default gateway here is 12 Philip, okay, it simply means all the residents within this Phillips Street, they must have this default gateway in common, which is 12 Philip. Meaning the ID of this their gate is called default gateway, or the exit point for them to get out of this network and reach another network, in this case the Kelvin Street. The same way, or the same thing is applicable to all the residents within this Kelvin Street also. For them to reach the Phillips Street, they need to pass through this default gateway. So it's important for any system to have a default gateway when you want to reach another system or another client outside its local area network. That is what that one is. Okay, then we talk about the IDS and the IPS. The IDS, intrusion detection system, and the IPS, intrusion prevention system. These are more or less like security devices. So for you to be able to actually get to a network prevention system, so it prevents, and that could be network-based intrusion prevention system, or network-based, or host-based rather, either network-based intrusion prevention system or host-based intrusion prevention system. So that has to do with security, more is like firewall. So we want to, what's it called, filter traffic and make sure that suspicious traffic are not allowed to enter our private network. But in a situation where the hacker tries to bypass that and be able to get access to our network, now before any harm is being done on our network, we want to make sure that we detect that suspicious activity. Okay, now that is where you need to now deploy the intrusion detection system, which could be either network intrusion detection system, which is the NIDS in this case now, or the host-based intrusion detection system. Okay, so that is how that one is being done. Then after that, we'll talk about the media. Media talks about, well, the media could be wireless or cable, meaning the medium in which your computers are connected together. So they are going to be connected either wireless to Wi-Fi or via cable. Then you have network interface card. So then you have the network interface card is also referred to as your LAN card. So it provides the connection points between your connector and your media. It's more or less like a converter that converts from analog data to analog to digital media, it converts your analog signal to digital or vice versa. So meaning from source